Yeah.
Even if it is a complex number, by your question, the modulus is still not negative. The modulus of a complex number is what we denote by R when we write in either polar form or Euler form. Is that not?
Yes.
Has your R ever been negative?
Oh, yeah. No,
And
never.
remember, the modulus of a complex number, the complex number is represented by a line on the Argand diagram, where the modulus of the complex number is what of the line?
It's the length of a line.
Can you say the length of a line is negative?
No.
So be it real or complex, you shouldn't have negative for modulus.
Okay. Thank you.
A good question, though. Good question. Checking your work now. I will start with Elson. Elson, this is the first one. Just the first one, right? So that's correct. Elson, you don't need to write a sentence. Instead of modulus of any R, write like a mathematician. Can you hear me, Elson?
Yes.
Instead of a sentence, write in maths, stuff. So Yanko, I'm checking, okay. When you say then it has no solution, what do you mean it has no, what is it?
Okay.
Okay, then the problem has no solution, or then the equation has no solution. Okay. All right, that's better. Then when you move your, the line where you have minus 5x equals plus or minus something, the minus 2.
Yes.
Put the minus 2 first. The plus or minus should be later.
Okay.
Remember how we arrange completing the square.
Yes.
Apart from that, every other thing looks good. Good job. Same with Alex. Alex, minus 5x is equal to plus or minus 12 minus 2. Let the minus 2 come before the plus or minus 12, which is what you did in the second line. When you said x is equal to, you had minus 2.
Okay.
Okay. I don't know how this guy got. Why do you square both sides? I just show you an example. Dude, why do you square both sides? Why do you have a quadratic equation?
Oh, that's my bad.
But we just did an example. If the absolute value of x is equal to a and a is positive, then x is equal to plus or minus a. Please, this is maybe a correct solution, but unacceptable to me because it's just waste of time. Elson, I've seen your correction. Please redo it and send back to me. I don't appreciate this solution. It might be correct, but it's not appreciated. Yeah, this looks good. Of course, the answers will be the same, but why do you have to go through a longer route to get the work done? Okay, so that makes sense. Can anyone try 2A? Let me share with you what 2A looks like. 2A. Let's look at the screen and see your 2A. Try 2A, please. Another example. Now, look at this example. Can I have everyone's attention? You see, this example, one of them is this, which you have just done. This is the other one. This is where you need to square both sides because there are absolute values on both sides. But they did it in another way, which I want you to listen to. Then I'll show you another way. So for this one, you have done it already by applying the property. Okay? And so, but I just want to show you, play this for you as well. Can you hear the audio?
Equations which involve the absolute value function or modulus function are called modulus equations. If the absolute value of x, or mod x, is a positive constant a, then x could be a or minus a. In part A, the absolute value of the fraction is 4, so the fraction could be 4 or minus 4. We can split this into two separate equations, each giving a possible solution. First, suppose the fraction is 4. We multiply both sides by 1 minus x, expand the brackets, then solve the linear equation for x. Next, suppose the fraction is minus 4. We multiply both sides by 1 minus x, expand the brackets, then solve the linear equation for x. So, x is 2 over 7, or 6. In part B, the absolute value of one expression equals the absolute value of another. The size of the expressions is the same, so either the expressions are equal or one is the negative of the other.
Do you understand that analogy? Do you understand this reason? If two absolute values are equal, it means what you have here is exactly what you have here, or the minus. Because remember, absolute value only takes care of minus. So is it that they have the same number in it, but the only difference is that they have minus. Do you understand?
Yes.
So whenever you see this, you can do it this way directly, plus or minus also. Hello, confirm if you get that.
Yes.
Yeah.
Yes.
All right, let's move on.
We can split this into two separate equations, each giving a possible solution. First, suppose the expressions are equal. We have a linear equation to solve for x. Next, suppose one expression is the negative of the other. We expand the brackets, then solve the linear equation for x. So, x is 2 over 3, or 4.
Now, another way to do this, because it has absolute value on both sides, you can square both sides. If you square both sides, the purpose of the squaring both sides is to be able to apply this property. Let me show you. The purpose is to apply this property. When you square an absolute value, it's the same as when you put the square on the number itself. So solving the same question, the question is absolute value of x plus 1 is absolute value of 2x minus 3. So one method is to say that, oh, if this happens, then the x plus 1 must be either 2x plus 3, it's either 2x minus 3, or it could be the negative version of it. Because all the absolute value does is to remove the negative sign. So if you have absolute value on both sides, then the numbers inside are the same, but they are just plus or minus each other. That's like the likelihood. Understand? So this is the first method. The second method, however, is this. For absolute value of x plus 1 equals to absolute value of 2x minus 3, you can square both sides. Again, no need to square both sides for the first case of having is equal to a constant. Okay? This method will sometimes be inevitable. When we get to inequality, we will be squaring both sides because of absolute value a lot. So, absolute value of x plus 1 all squared, absolute value of 2x minus 3 all squared. So by the property of absolute value, this property number 2, When you square absolute value, it's as good as remove the absolute value and put the square on the number itself. So which means this is as good as x plus 1 all squared, while this is as good as 2x minus 3 all squared. The reason for this is because the absolute value of y all squared is the same thing as y squared itself. Any questions? I can't hear anything. Any questions?
Questions?
All right. So from here, we can open the brackets x squared, 2x, 1, 4x squared, 12x, 9. Then we can do minus 3x squared plus 14x minus 8 equals to 0, which is positive 3x squared negative 14x plus 8 equals to 0. Factors of 24, that gives that's 12 and 2. Or any other method that comes to your mind. So 3x, x minus 4, negative 2, x minus 4 equals to 0. So is either x minus 4, no, this will be x minus 4 bracket 3x minus 2, which implies either x minus 4 equals to 0 or 3x minus 2 equals to 0. As a result, x is equal to 4, x is equal to 2 over 3, which is exactly what you got if you use this method. Understand? So again, so in this case, if you square both sides, I will allow it. But in the other one, I don't want to see it. But again, it's better you use this. It's short and it's straightforward. So that's that about the second aspect of this. So with that, you'll be able to do this number 5 later. But then you can be asked to solve graphically. Again, this is not something difficult. To solve absolute value modulus equation graphically, plot the graph of one side, plot the graph of one side, find out where they meet, right? Graph of x plus 1 is the graph of x translated by 1 unit to the left. Graph of absolute value of x, remember, is that V shape. Remember the V shape that I'm talking about?
Yes.
Yes.
When it's translated by 1 unit, this is what you have. Then graph of x plus 1, x plus 2, x over 2 plus 2 will be the straight line. So where they meet is this. So all you have to do is use your calculator. So press your calculator and follow the instruction I'm going to show you now on the screen. Quickly, when you finish, tell me.
I don't have my graphic calculator. Do I just use decimals?
Okay, but it's better you have your graphic calculator. Whenever we are having a class, you should always have it. I don't have to tell you to bring it. Because you are supposed to learn these functions, how this the calculator works. So it's something you will you will use between now and Form 6, not start learning them in Form 6. And when I get to a topic, there will be need to show you, okay, this is how to use it on your calculator. So you don't now say, oh, I don't have my calculator at that time. It should always be with you. So take note next time. And you don't
How
need
do
to
you
ask me.
enter absolute value?
And you don't need to ask me if, can I finish, guys?
Oh,
And you don't need to
sorry.
ask me if, oh, do I need to bring my calculator to class? Please, nobody should ask that. It's as good as saying, do I need to bring my pen to class? Yes, what are your questions?
I cannot find absolute value.
On your calculator? That's weird.
Yes. I can't find it on the buttons. I might be blind, but like.
It should be somewhere. I
I'm
don't
just
have
going
it.
to this. I'm just going to do the square of the square root for now, because I can't find it either.
Because on my other calculator, there's a
I don't
button
have
called
that kind of
AB answer.
calculator
That's
with
absolute
me.
value.
I don't have that kind of calculator with me, but you're gonna have to Google something. Okay, how to do absolute value on calculator CG50 or whatever later. I'll send you this screenshot, this PDF later. Please make use of it. Anyway, you plot the two graphs and you try to see where they meet. I'll send you this, make sure you try it on your own and attempt all the questions on the page of the book. Understand? So these are questions for graphical aspect. So you draw the graph of this, draw the graph of this, and use that to solve. When they say sketch, you use your calculator to draw the graph, but you have to draw it in your book. Understand?
Okay.
The question says sketch the graphs of this. So you do a sketch on your book, not to scale. You do a sketch of this on your book, not to scale. The calculator can help you plot it to be fast. Nobody's asking you to memorize that, which of course we expect it to be able to do. Then the same way this aspect has been traced, that's one. So you might have some additional information from the instruction. Can you see this?
Yes.
Yes.
In this example, we solve a modulus equation graphically. We graph the expressions on each side of the equation on the same set of axes. On the left-hand side, we have the absolute value of x plus 1. We can graph this by hand by separating the graph into two sections. X plus 1 is positive when x is greater than or equal to minus 1. So for these values, the graph is simply y equals x plus 1. X plus 1 is negative when x is less than minus 1. For these values, the graph is the negative of the expression x plus 1. So it is y equals minus x minus 1. The right-hand side of the equation is a straight line with gradient 1/2 and y-intercept 2. Alternatively, you can plot the functions using a calculator. Click on the icon if you need instructions. The graphs intersect at 2 points, and the solutions to the equation are their x-coordinates. So, x is minus 2 or 2.
Understood? Okay, so I'm going to send you screenshots later. Please make sure you try these problems, and that will be all about graph modulus equations. Any question from anyone? Alex?
Not for me.
No.
No, but I found the
No.
absolute value.
Okay, so where did you find it?
You press option and then F5 for numeric, and then it should be the first one, F1.
Can you guys hear that?
Should
Can
be
you repeat that again for everyone?
Oh, I see. I got you.
Alex, I'm waiting for you to confirm.
I can't find the option.
Someone talk to Alex. I don't have the calculator with me. I have
Option is next to shift.
here, shift, and then option, OPTN. And then you click that,
Alex, can you get that?
and this should pop up. And then you press numeric. And you get ABS.
ABS.
That's absolute value right
Oh, epic. Thanks.
Thank you, Elsin. Thank you, Elsin. All right, guys. So, okay, great. So I'm going to send you the instruction in PDF format. Please save it and make use of it anytime. I think I've sent you a whole list of instruction earlier, like a PDF bunch of PDF stuff in the Google Drive. Okay, calculator instructions. Did I send you guys or just from 6?
I do not recall.
Okay, I will look at that and I'll send you. Or better still, when I'm on different topics, I'll send you the instruction one by one. Okay, guys, this is where we will stop for today. I will see you tomorrow. What time do we meet tomorrow?
10.
Did you say 10?
Yes.
Yes.
Okay, we'll see you 10 a.m. tomorrow. So we'll be looking at absolute value inequality. And please, we'll be using the calculator again. Okay, see ya.
Okay.
Goodbye.
Bye.